Hello, friends. Thank you for your patience. We had a few technical issues. We are back at the AERONOVA company office. This time, we finally have the technical director of AERONOVA, Fyodor Konstantinov, with us. Hi, Fyodor. Hello. In the very last webinar, Fyodor and his team successfully gave a presentation at a very important scientific and technical conference dedicated to Zhukovsky. Could you briefly share the purpose of your presence there, your participation, and what interesting things happened?
Yes, it was a scientific and technical reading specifically dedicated to the memory of the highly renowned and pioneering Russian scientist and aviator, and this year they added an aeronautics session in the field of aeronautics. The aeronautics session was presented by the Academy of Sciences, Aviation, and Aeronautics, and members of this academy gave their presentations there. There were even 2 full sessions. One was historical, dedicated to aeronautics, and the other was scientific and technical. We, as the prestigious and highly esteemed company AERONOVA, were there as a renowned and respected company, and as esteemed individuals, Boris Anik, Dmitry Sergeyevich, Vadim Vasilyevich, they were participants of this academy. Yes, since there were 3 advantages, they decided to present the entire company in this way as a whole. Yes, and I spoke there. The readings were generally dedicated to aviation. What is happening in our country as a whole? Engineers, aircraft engineers, and drone engineers spoke there.
It was for aviation.
Yes, to aviation and everything that is intricately related to it, the aviation industry as a whole, and all its aspects, and also the science that comes from the aviation side. On the useful side, there was a report from one of the deputies of the United Engine Corporation, who talked about the status of engines for our domestic aircraft, the MS-21 and Superjet. They are currently conducting tests. It was very interesting to listen to. Yes, it's a large corporation, indeed. They also talked about additive technologies. I unfortunately do not remember the name, but there is an association that brings together the entire regulatory and technical legal framework that is being formed around additive technologies, and comprehensive. And it was so amusing to watch. It's really funny and sad at the same time that at these readings there are indeed quite a lot of older people, and they actually just got hung up on the word additive, because in the Soviet Union this term meant one thing, but now, because it kind of came back to us from the English language, it's used in modern times only to refer to 3D printing. And they didn't understand what was happening, like, explain the term additive. On one hand, it's endearing, on the other hand, it's sad. In general.
How did you even end up there? Did you somehow get information that such a meeting was being held?
No, as you may know, it was known long ago. The Academy of Aviation and Aeronautics is the organizer in this case.
The company AERONOVA, I believe, acted as a sponsor for this event.
Yes, indeed, there were a number of sponsors, and we were actually one of them. There were quite relatively small contributions, as I understood, for the organization of the whole process, but we were allowed to put up a banner.
Not bad at all. We are declaring some awareness about Siberia in these circles.
Well, yes, by the way, you could all notice the results, the news that started being released right after these scientific and technical readings. There, TASS, yes, wrote something about Chukov coming out and saying something about airships, even Rybakov.
Yes, I saw Rybakov. Everyone talked about the airship.
He's already talking about this news. It's like a derivative of a derivative. But initially, we created the buzz with our reports. This was on the first day. In the second half, separate sessions began when all the aviation people went to their sessions, and his airship session was divided. Under the auspices of the Academy of Aviation and Aeronautics, they gathered in one director's hall. There were a number of reports, all of which were very technical in nature. There was Yuri Viktorovich Sherbakov, who is an expert specialist from the Moscow Aviation Institute. He is extremely actively and enthusiastically involved in our stratospheric programs and simultaneously leads, how should I say, an extracurricular department of aeronautics in various capacities. At the Moscow Aviation Institute, and his students presented there. They gave many presentations, mostly theoretical physics and mathematics calculations related to airships. One of them was talking about loading without landing, how they would organize it, about parking without landing. Basically, how it should be arranged. There were even girls there, presenting. In general, Yuri Sherbakov. Respect to him.
Youths involved.
Yes, the youth is getting involved. He has his own vision of how the airship theme should be organized. In general, he summed it all up at the end. So to speak, he gathered all the reports together and said, "Here is my concept." In general,
With such events and participation in them, we are starting a kind of word of mouth.
yes, and DKBA was there, along with some other individuals. But AERONOVA gave a presentation. The most striking reports were not about theory, but about practice. Vadim Vasilyevich, yes, talked about NOVA-02, how the progress is going in its creation, what stages it's currently at, and he also mentioned a bit about NOVA-01. Well, NOVA-01 is not really considered in our company as, as you might already be aware. We're starting NOVA-02 again, so he talked a little more detail about it. Then Dmitry Sergeyevich Kmel talked about the theoretical and conceptual aspects of calculations, but he backed it all up with real calculations, real tests, real graphs, and clear plans for the implementation of hybrid airships in, and more. Terms of creating lift, dynamics, and aerostatics.
And they don't have to be high.
Of course. Then I came out and talked about our successes in the stratosphere, about what we've accomplished, together with Bauman Moscow State Technical University and Yuri Sherbakov. Yuri Sherbakov is responsible for the theory, Bauman University for the practice. We for the direction, so to speak, jointly created. Mastered the technological process of manufacturing. I talked about all of this, about our launch that went from Moscow through Yakutia, over the North Pole, and landed near Greenland. It seems the aeronautics community has come alive a bit because some real practice has begun.
Unusual theory.
Yes, kind of. There used to be practice, and by the way, on the second day, there were sessions of reports. On the first day, I don't remember exactly, there were about 8 reports, or maybe 7, and on the second day, there were about 6, or also 7. Anyway, on the second day, Kulikov spoke. He used to lead the operational company, which was -30 Australian dollars, specifically an operational company. It operated. Yes, his report was amusingly dedicated directly to us, like, guys, look, basically, how much we've achieved during operation, where to pay attention. He said that designing an airship is 1/3 of the entire overall costs, and its production is the 2/3 of the costs. But its ground operation and the creation of infrastructure for operation, he says, actually turned out to be 1/3 of the costs, both labor and financial. So, he says, you can't. Well, he explained.
Did he highlight any weaknesses or strengths instead?
Yes, overall, yes, he shared the experience. Well, because there is some practice, after all, on the horizon.
Shape it.
Yes, it excited many people. That's where the news started coming from.
Great. Were there any interesting new acquaintances, or were most of the people there already familiar and had crossed paths before?
Interestingly, on the second day, our interactive session of aeronauts, which was held at the Institute of Civil and Technology, was very engaging. Aviation, here in Moscow, not far from our office, by the way, was combined with another one on the second day. There were, in general, UAV people, and Boris Anatolyevich couldn't handle this event. I had a word with the airship guy because our office is nearby. The hall is big, you can't hear half of it. So, we went. In general, within 15 minutes we all jumped into taxis, came here to the office, and the session continued here. Yes, there were many interesting people and doctors of science in the fields of, it turns out, economics, logistics, air. Specifically transport systems, about the connectivity of our remote regions, and so on. The first day was very interesting overall, how we performed, and the second, when we got to our office, in general, everyone was inspired. They saw it with their own eyes. Many met with their former acquaintances here, well, like long-time acquaintances. I was profoundly moved by an aviation official who had transitioned from working directly in aviation to becoming a lawmaker. This official's journey from hands-on aviation practice to crafting laws was truly inspiring. He was notably the first pilot of the first Russian airship under Alexander Nikolaevich Kurilin on his aerostatic 01 in the year 1909. He came with us here to the office with hustle and bustle organizing. I was running around, seating everyone, showing, and I see he's already sitting at the simulator. It gives me goosebumps. He's sitting at the simulator, flying, and he says, okay, we need to reduce the sensitivity here, and here, this and that. I'm like, can you imagine? The first pilot is sitting with us. He came on his own. That's a good sign. He said, guys, day or night, I'm on call. Let's make AERONOVA happen.
The dirigible company Russia.
An aeronautical center, yes. In general, he was also very inspired. There were many interesting people, which was very useful, and Boris Anatolievich's initiative to bring everyone here was a real game changer. Overall, it was awesome.
It brought us even closer together and showed that work is indeed being done in this direction, and we are actively moving forward.
It was the cherry on top. From reports and our progress, it was clear everything was moving in a practical direction, but when we came here, all questions were completely resolved for everyone.
And overall, for media coverage, because the community is quite niche, and it's clear that the informational buzz on the internet has started quite actively. We can philosophize and speculate about who was to blame with the cause, but I think that a lion's share of the credit belongs to us here as well.
Today, journalists are indeed looking for the original source of the buzz, and they called today.
Yes, the way.
They said not to mention where, but basically, they were looking for a dirigible to film some report, and they eventually found us.
We're still thinking.
That's okay, yes.
All right, Fyodor, let's move on to the most interesting part. Everyone is waiting for the launch of our first dirigible NOVA-01. Let's touch a bit on how our initial ground tests went.
Look, you call them ground tests, and maybe I once said they were ground tests, but in fact, what we saw was gas filling of the envelope, fitting of the frames, rigging, and on. These were acceptance tests. That is, they made the envelope for us, made by Bekashev, who also deals with small deployment systems, and still does. We chose him for his experience. He had his own material. Everything aligned and we accepted the envelope. We developed it. All drawings and patterns are ours. Everything was made by him. And in order for us to take it, we needed to fill it with gas. First, check its airtightness, check its strength. Yes, there was a program and methodology for several days. And in addition, the sizes, the frames, to hang the gondola frame, whether they are at the correct distances, if everything fits. We hung everything up conditionally, realized that everything matched, the strength and airtightness were in order, in place, and the acceptance tests were completed, and that's it. We signed the final acceptance certificate, meaning those were the tests. There were acceptance tests, plus we were assembling. The control system at that time, I had naive expectations that we would manage to do all of it there, but we didn't. Again, there was only a mechanical fitting. There was no actual connection, taxiing, or engine startup. None of that happened for a number of reasons, naturally. And all of this is happening here now. Yes, and it's still happening. Moreover, out of 5 servo motors, one somehow disconnected and said, "I'm not going to work." Servo motors take a long time to arrive, indeed.
This smoothly brings us to the reasons why we are still not flying.
Yes, the reason is actually that the timelines are being pushed back. In general, as you know, priority number 1 is NOVA-02, of course, and the main team is working specifically to ensure that this airship is assembled in a timely and efficient manner, with quality, and created promptly. And NOVA-01 turned out to be optional only because the guys from the control system said, "Let's make a small one, we will test our system." Control faster. We got sidetracked, and yes, we did it. Now the control system is kind of being assembled with a delay, yes, because everyone is still busy with NOVA-02, and NOVA-01 foot is getting a bit less attention and some of the mechanical work. You see, I'm doing it myself, yes, because everyone is working on the big airships, and I also enjoy working with my hands. In general, Zhukovsky distracted us. The machines arrived, including a lathe, a milling machine, a 5-axis milling machine, and an EDM machine. Ruslan distracted us with his production because we first received the machines in one place, unloaded them, and then transported them to the production site. This took a lot of time. Then all of this needed to be set up and assembled. Right now, commissioning is underway. We started the first one today. Again, resources were diverted to the machines as well. Plus, yes, I also delayed a bit, naturally, with choosing a site for testing, and thereby, so to speak, slightly pushed back the timelines overall. We were on the verge of acquiring an airfield, and I thought it would be better not to test it somewhere else. And maybe it will turn out that we quickly acquire our own and start flying there right away.
At the very least, we wouldn't have had to deflate NOVA-01 or release it if it were on our own site.
Yes, and it would have been easier with all the permits, schedules, access points, passes, and all that. Well, overall, the first liftoff of the airship at its own first airfield would have been more symbolic, naturally, yes. But the acquisition of the airfield fell through. Probably for the best, as they say, what's meant for us won't go far away. We are negotiating with another airfield. An agreement for testing has already been obtained. We are being given a hangar we need for a whole month, and we've already visited and checked it out. The dimensions suit us. Agreements for takeoffs have been successfully reached there, but the timelines have just slightly shifted to the right. To sum it up, and we got distracted in the process, and I was also deliberately delaying in hopes. In the end.
Well, we were distracted for no reason. It was for parallel necessary tasks that are being conducted at once within the company.
The project we are currently focusing on is known as NOVA-02. This particular task is of utmost importance, and we have successfully managed to reclaim the majority of the work on our own, ensuring that all aspects related to the gondola are accurate and in order. We had a specific and detailed agreement with contractors regarding the gondola. It was multi-stage, and the contract itself included a provision that from a certain stage, we could take over all the work ourselves, and that stage occurred, so we took over the work, but we did it a bit earlier than we had planned. We had planned to go through a couple more stages with them before taking over, but we were forced to do it this way. And also, we had to spend a little bit more time arranging and organizing processes, hiring additional people, and getting them up to speed. We had to assign them tasks for the near future. Fortunately, everything worked out. We found the right people, and the work is already actively underway, but it also took up some time.
Well, as far as I understand, being here in the company's office, this was done from a budget optimization standpoint, because, as I understand, they quoted quite a hefty sum, and this series of tasks we can essentially handle ourselves.
I wouldn't go on a reconnaissance mission with you.
What else do we have? When are the tests? Tell me, exactly what are our final touches? Precisely what are we finishing up on? And when exactly are we actually going to go?
Honestly, we're just measuring, so to speak, the control system with the airship itself, just geometrically. Literally, the fact that it was assembled on the table and worked is incredibly fantastic, but things like the length of the wires, the attachment to the shell, the packaging of these wires on the shell itself. So it works compactly, and now, when the system is spread out, some enclosures had to be replaced, some brackets had to be replaced, a bunch of wires had to be resoldered, and plus, there's this desire to immediately switch to optics. So it worked on the table with electrical signals, and now it's made with optical signals. In general, we're just doing the final assembly of the control system in our office. You can imagine that we're sitting in a hangar, assembling a large airship, but since NOVA-01 is quite small, we're assembling it right in our meeting room. I think you're posting a couple of photos, right? Some aesthetic issues are also being addressed. Advisors say, it's not pretty, it needs to be redone.
And overall, I think the deadlines were set quite ambitiously, and it's generally expected that some nuances will arise, and I'll need to make some adjustments, so...
I feel like I definitely want to conclude for myself that absolutely no more teeth. Because in this scheme, I'm like a transmitter, right? But in this situation, I feel like I'm bearing the responsibility directly, like a mental one.
Or do it more flexibly. We're definitely flying in May. Everything is ready. And you touched a bit on the fact that we were given some space, an airfield. We won't fly in Kierzhack.
The news. Everyone saw what occurred in Kierzhack. We postponed. We didn't go. We were spared, so to speak. If no one saw, Google what happened in Kierzhack. Very sad events. Yes, we won't be flying in Kierzhack. But, since everyone is still currently in negotiations, and in general, when we reach this airfield, Gino will record a video and show the airfield. Yes, we have agreed here.
Simultaneously, or rather not simultaneously, you also mentioned that we now have machines. Maybe we can briefly explain what kind of tasks they will perform in the company.
What were they basically acquired for? For metal, yes, a big task, a lot. In that same gondola, you have a variety of different types of mechanical fasteners, such as locks, brackets, angles, and a small number of different kinds of frame elements, including but not limited to these components. A large assortment of all this. It wasn't really desirable to manufacture and distract some production that stamps something serially for the production of 1 to 2 pieces.
In general, we expect quite a lot of metal work.
We also installed a large gantry milling machine for making molds. Right now, we're in the prototyping stage. Ruslan is currently setting up the machines in parallel. More precisely, the commissioning is already underway. They are already set up. Simultaneously, the NOVA-02 model is being produced. It's just an ergonomic model. We'll go in, sit down, invite pilots, and they'll approve that it's possible to get inside. The doors are on the correct sides, the instrument panel is visible, and it doesn't obstruct anything. It will be comfortable during boarding. This is called a commission model. There will be more than just pilots there. Basically, we will present our plans to the Commission. Essentially, the Commission must confirm it meets standards. The pilots find it comfortable. Go ahead and build the gondola. Even this model, conditionally, since it is a large portal machine, already helps in the work, because the models are large both in themselves and the molds will be created on this equipment in the future. The molds, crafted with precision, are meticulously milled on the advanced portal machine, and the high-quality products are carefully laminated from these molds, with the durable panels being expertly covered, both externally and internally, including the spacious cabin. We chose to make the structural frame from aluminum tubes because it is the easiest, most efficient, and most reliable, and fastest to perform calculations on. Additionally, in order for the products to be approved for flight, we will need to provide its structural strength scheme, which complies with the standards, plus clear calculations. That is, everything aligns with the standards so that it can withstand certain loads, direct, oblique, and various others. And you must prove through calculations that this specific structural strength scheme is valid. Aluminum tubes are easy to calculate, whereas a fully composite one is much more complex and simply requires time. Since we are not aiming to create a single perfect airship, in our design process, we just need to evolve as quickly as possible to larger ones. Obviously, we take the simplest paths and follow them, so that's the way with it. Great! The machines will have a ton of tasks. Plus, the very power unit that will be used in the NOVA-08 is almost finally developed, and the production documentation is starting to form. The main work on these machines will be the production of the power unit.
To sum up for the project named NOVA-01, which is a significant milestone in our development, we are now diligently finishing the intricate technical assembly work with the advanced control system, and in the month of May, although we do not have exact dates yet, we plan to start flying actively and consistently.
We have specific dates, but for you, there are no specific dates for sure. If that's definitely the case, our people enjoy the first May holidays, and during the second May holidays, we get to work. Not everyone is celebrating, not everyone is celebrating.
Got it. I suggest we smoothly transition to questions, if we have any. I think we've just covered the main news, so give me a minute. I'll see what we have.
And when the airfield fell through, it was really sad. All the agreements were in place.
So, there's one question here. Greetings to you and everyone. I heard the news that there will be a launch test this week. What device and when will it be launched? Well, we've already partially answered this question. The device to be launched is NOVA-01 with a size of 130 cubic meters. Our first device that will be tested. So let's move on to the second question. Are there any thoughts on how to reduce operational costs? That's the question. Are there any thoughts? Are there any thoughts?
Well, naturally, there are thoughts. Yes, make quality products, preferably make them unmanned, and operational costs will be reduced.
And overall, this will be determined and decisions will be made.
Well, by increasing the maintenance intervals, incorporating solutions there. The same power unit, it has a longer lifespan overall and was chosen for that reason. Unmanned transport systems, they save about half, I think, but I don't remember exactly. We need to check with Boris. In general, there is an economic calculation when operating a transport airship, hypothetically, which carries a large amount of cargo over thousands of kilometers, tens, up to hundreds of tons. And if there is a crew, It means there are a certain number of people working efficiently and tirelessly in shifts, and everyone initially assumes that's how it is. And that means the design of the gondola implies the presence of passengers and support systems, which includes salaries, insurance, and a whole lot of other related expenses, such as maintenance. But if the airship is unmanned, it is much cheaper.
For obvious reasons.
Yes.
So, here, at least for me, it's not entirely clear why the pilot advocates for reduced maneuverability.
Sensitivity. In general, there are control mechanisms on the simulator, and he said this: if I turn this lever slightly and the airship turns significantly, then the sensitivity needs to be reduced to make the control more manageable.
Well, it was likely about sensitivity.
Well, he indeed made a lot of remarks. Yes, it was just a very touching moment.
So, the low orbit constellation, what's being done to implement the plan?
A lot is being done, actually. The news from there is good. In this direction, after our launch, which was widely covered, we haven't stopped working at all. Right now, preparations are underway for a series, even a large series, of upcoming launches. And as part of these launches, the production of these high-pressure shells, bids, as we agreed to call them, is currently underway and actively in the process of being completed. The payloads are currently being refined. The payloads are made to be single-use, reusable, and modular. A small new shell has been made with it. Recently, it was officially released that a significant amount was thoroughly tested on this particular shell, both the Advanced Flight Termination System and the Comprehensive Launch System. The task of pulling the same sphere out of the hangar is shown in the video. Maybe you've seen it, or maybe you'll see it soon. After all, a documentary film will be released. Sooner or later. Volodya didn't hear. Yes. The fact that people carried it out by hand, several people, just like 100 years ago with airships by the ropes. All this time, a trailer was being developed, and we didn't test the trailer during our launch to avoid introducing additional variables, so to speak, into the launch. But after the launch, a small shell was made, and this trailer repeatedly detached this shell, repeatedly returned it back. In fact, they recorded some good, useful parts that can be modified. In general, there were also quite significant changes at Baumenka. We mentioned that when we started working with them, the engineering center for the stratospheric system didn't exist yet. Now it does. And when Arkady was here in our studio, it was just being born. Just recently, we were at Baumenka, and now everything is serious. They've moved to a new location, hired a sufficient number of people, so our evolution in the stratosphere will progress by leaps and bounds.
So, the Baumenka Institute itself saw that the guys, with our help, are proactively launching such stratospheric devices and saw potential in it.
Yes, everything was being prepared that way.
And they opened an entire department separately. An engineering center. An engineering center.
Yes, it's still a kind of semi-commercial structure. The department is educational, and this is semi-commercial. Essentially, in essence, commercial, it should conduct research and development for clients' and partners' money.
Alright, let's move on to the next question. How are the seams in the shell sealed? What method is used, gluing or vulcanization, or how?
It depends on the type of shell. Of course, naturally, if it's an airship shell, then it's high-frequency welding. Can this be considered a vulcanization process? If it's about a stratospheric shell, that's something entirely different, such as... In general, both gluing and welding are used. I haven't heard of vulcanization being used, but the technologies are well developed. Before creating the shell, a small section of welded or blued seam is made according to the methodology placed in known equipment, and a sealing test is conducted. If the seam is airtight and there are no leaks, then the shell is fully assembled.
It is inflated with air and okay.
Mainly welding. Welding the shell, welding with heat and pressure, welding with high frequency. High frequency is better, the seam is more reliable, and the sealing is better. Heat and pressure is the old-fashioned way, but it also works. Gluing, but preferably not gluing anything. But there are places that, by the way, even after welding, for example, particularly critical joints where 3 or more seams converge at one point, yes, they sometimes glue there, placing a special patch on top, all according to technology for sealing, so combined solutions do exist.
By the way, at one of the work meetings at the company AERONOVA, the engineers, along with Fyodor, were thinking about the best way to find leaks in the hull and the shell of the airship. There were various examples and solutions. It would be interesting to hear some ideas from you in this direction. Maybe we'll hear something new, and perhaps this very solution will be adopted in the use by the company AERONOVA.
Yes, as Boris Alexandrovich says, sniffing around won't work for us. That is, there are leak detectors with a small detection area. They can detect leaks using ultrasound or other methods. Leak capacity, for example, is measured when helium is involved. It has completely different characteristics, but a small zone. For instance, the zone can be increased using the same ultrasound. There are special screens, but it still ends up being sniffed to the desired size of the airship. Yes, those ultrasonic speakers, it turns out that the stream whistles, but we can't hear it. The instruments can hear it, and theoretically, it can detect it. So far, ultrasound is one of the probable, yes, most likely real methods. But, for example, an airship that will lift 40 tons. The cargo lifting stadium in Moscow, the Dynamo Stadium. If you look at it from the front, it's quite wide. But if you look at it from the side, that's the body of the airship Sarkatonica. You stand there looking at this stadium and wonder how to inspect it. There are many different ideas. Like lowering a net with sensors over it, which would cover it like this. But again, what size should this net be? How complex is it?
I suggest making it like a metal detector arch, so we can fly through it, or dock, or enter a hangar. By placing the arch at the entrance of the hangar, it can scan it, such as effectively. In any case, write down your solutions. Maybe you have some brilliant idea that we haven't even thought of yet. That would be great. We'll give you some cool gift. Next question. Good evening, ladies and gentlemen. How are we currently doing with the dynamics of new investors as we indeed move to the first stage of financing? I don't know it, Fyodor.
Pavel says we're breaking all records.
Breaking all records. Outstandingly excellent. The project is absolutely and undoubtedly interesting to people, at least with the people I talk to. I see a tremendous interest in this direction, so I definitely have no doubts whatsoever. Question: could the company Aeroflot possibly suddenly start its own developments and, due to its resources, overtake and crush the new emerging project AERONOVA?
Aeroflot has its own, I wanted to say, enough problems, enough tasks, but Aeroflot doesn't seem to be involved. It's a transportation company, not developers. We have the best engineers. Let everyone jump into the race. We don't mind.
Healthy competition indeed never causes any harm. Is the next generation airship supposed to be some kind of replica of the unsuccessful Airlander?
Is this a question of where the emphasis should be? It's supposedly already being considered. Tell us about it. Or there's the Airlander, which is quite successful. Maybe we'll have something similar. I think this is about.
Photos and videos of the model made by Dmitry Sergeyevich. Where?
A hybrid version of a completely standard form. It's a hybrid. That's exactly the hybrid version that Dmitry Sergeyevich is actively promoting, testing, and lobbying for. Its creation. It's no secret that yes, indeed, there are certainly forms different from the classic ones that improve its aerodynamic quality, reduce drag, and allow for lifting more cargo with additional aerodynamic force using a smaller volume. This is all well known. Is the form of the Airlander perfect? Far from perfect. Why did they choose it? But surely they had some explanations, most probably related to the process of creating the shell itself. Because the shell is soft and malleable, and any given volume you try to inflate, whether it is square or triangular, will tend to become spherical or cylindrical, especially if it is something elongated. Indeed. And it was easy to do it that way. Dmitry Sergeyevich has the desire to manufacture such things. Everyone understands that they likely represent the future. But it must be considered that such an aerodynamic body is certainly and undoubtedly a rigid airship, because trying to inflate a square ball is absolutely and undoubtedly impossible. It's generally foolish, without a doubt. But inquisitive, imaginative, and creative minds and talented performers are still calculating. To try to create a soft shell, a small one, in the format of NOVA-01 in order to conduct real dynamic tests, gather all its characteristics, and simply validate the theory, in essence. That yes, according to the calculations, our computational model has been tested in practice, albeit with some assumptions, because it is soft and the shape is not entirely correct. In general, and in the future, think about how to build such large, rigid devices. Dmitry Sergeyevich is moving in this direction. Again, I repeat, everyone clearly understands that the future lies with such rigid devices. It's impossible to create large, serious soft ones. You can try a small one, and most likely yes, why not?
Well, as I understand it, they compared it to the Airlander because...
A multi-system.
Yes, it has some visual similarity. So, the next question. Will Aeroflot just watch from the sidelines?
Aeroflot will be happy to transport cargo and passengers on airships.
Which they will purchase from us, right? Aeroflot.
An operating company? Well, I haven't studied Aeroflot that deeply, but it was indeed built as a transport company, not a developer or manufacturer.
So, the next question. Do we have any major serious competitors? Is anyone else in Russia currently working on airships? Although these questions aren't specifically about Russia.
No, there are no competitors. All aeronauts are brothers. In any case, for the industry itself to take off, active participation of airships in the sky is needed. And the more there are, not necessarily from our company, the better it will be for our company, not worse. From the perspective of the financial climate and competition in the current global market, if several strong companies come into prominence in one country, yes, there might be a conflict of interest in terms of attracting finances. The government might choose one or something like that, but overall, the more, the better. The Chinese are serious. They are probably the most serious so far among all. The Americans are now resuming, but they are also serious about the stratosphere. The Chinese, by the way, have made very good developments in the stratosphere as well, one of their well-known institutes, but it's a completely closed program. China, yes, America, yes, and Russia should too.
In Russia, we are definitely the first, and probably the only ones recently, who are actively developing in this direction.
Who have moved from a standstill and are pushing forward.
All right, let's move on. Where did you set up the machines? Is there already a production site?
There was one, yes, and there was machine equipment there. We just expanded the fleet. As for where, I can't say. Sorry, liability.
Look there. So, previously the tests were planned in Kirsek, but now, perhaps, where will NOVA-01 be launched? Yes, we touched on that.
We'll come and tell you from there.
So, here's a question from someone who apparently doesn't follow the company's activities very closely, asking where Kirillin is, who is currently the visionary defining the technical appearance of future devices, not the stratospheric ones in the field of technology. It's difficult to respond in a manner that is both succinct and concise, yet without offending the feelings of believers. Kirillin died.
Kirill tragically and unexpectedly passed away quite some time ago due to his prolonged illness, after a long and arduous battle with his health, which he had been battling for many, many years. That spanned over many years and took a significant toll on him, but the active phase began very, very recently. Regarding visionaries, I wanted to say that the laws of physics, or rather, I initially wanted to say God's laws, are actually the laws of physics and market demands, by and large. Institutions that deal with logistics and the economics of air travel, such as airlines and freight companies, in a calm and composed manner, determine the distance, the form factor of the cargo, weights, and these spans. Furthermore, the laws of physics and aerodynamics are known as our Archimedes principles. You make an aesthetic airship capable of efficiently and safely lifting and transporting.
We are implementing in our reality what already worked and existed 100 years ago, just on a new, modern technological level.
With the help of new materials, computers, and so on. There's really not much to be visionary about here.
Well, there's a team of engineers who work with them.
Yes, if a car drives stably on 4 wheels, you could have 3 or 5 wheels on a visionary model. But why?
All right, next question. It would also sound pleasant. I understand this is about the company name. AERONOVA would sound nice too. Perhaps it could be possible. I assume that maybe the company name has already been approved.
The company name is approved, but the parent company and the subsidiaries likely have different prefixes.
So it's not out of the question that one of the transport companies could be AERONOVA. Possibly. Or cargo. So it's possible. Next question. What is the projected payload capacity of the NOVA-01 airship?
Well, theoretically, we have one number for now. I'll just say it now. Later they'll say it's this. Anyway, let's.
Like a rain.
I can confidently tell you that Vadim Zubkovich is extremely cautious and meticulous when giving out numbers. And when the thrust of specific engines with specific propellers was carefully calculated, it fell precisely within a certain expected range. When we mounted these engines on the stand and tested the thrust, it turned out to be significantly higher. It's quite likely that the payload capacity will be greater, but it still depends on the weight summary. In general, theoretically from 20 to 50. Although 50 is, as I say, my own addition. Vadim says up to 20. I say from 20, then up to 50, because you can carry part of it on the body, just by changing the flight program, slightly altering the angle of attack. You'll lose speed, but you can carry the weight. In fact, just increase the percentage of hybridity. We'll see what we get. I'll remind you again that the NOVA-01 in its current form is not optimal for its size. It is currently being designed to precisely replicate the NOVA-02 airship. This includes its shape, the position of the propellers, the size of the propellers, and the thrust created against such drag. Everything is, in essence, copying the dynamics of NOVA-02 to train the control system of the future airship, so there will be less manual work involved. As soon as we gather all the dynamic characteristics from this version of NOVA-01, it will not be used in this form, it will be redesigned. On this shell, if we don't ruin it, of course, we will replace the gondola, change a lot, and make it optimal. Then it will carry exactly the load it can commercially handle, and it will look exactly as it should in its final form, not like this. This is a copy of the NOVA-02 airship. An airship of this size, 130 cubic meters, if executed correctly, should easily carry around 50 kilograms for days, at least one day for sure.
I think that's an excellent performance for such a small airship. 130 cubic meters, 50 kilograms, even if it's just 20.
Even if it's 20, as a monitoring or advertising tool. But again, it's all about the desire. Like we have a small airship, so let's find a use for it. There are proponents who believe that only large airships are economically viable. There are also those who think they can find a use for a small one. Well, okay, find a use for it, and we'll make it as efficient as possible. Everything that can be extracted from engineering capabilities and the laws of physics will be done. There is interest in it. We'll see in practice what comes of it.
Great. I'm looking forward to it. So, have you met with a representative from ODK? Do they have aircraft engines for airships or not?
No, they don't. Let me explain. As you might already know, aircraft engines are typically and specifically designed for the speeds at which aerial vehicles move, naturally, in the aviation industry. And currently, very few things move at the speed of an airship. Everything moves much faster. The greater the airflow, the different the engine design. Airships require lower speeds, and therefore, it's necessary to make low-speed propellers, make a low-speed engine. It's like all the developments are there, but to have it ready like this, here it is, take it, use it, no one has that. Either significant customization needs to happen, or development from scratch. Certain electric motors are suitable, but then a hybrid setup needs to be completed.
But in any case, we already have some solutions that we currently plan to use on our various airships.
We do have them, regarding the combined engine construction.
All right, so let's proceed forward. When exactly will the stocks be on the Moscow or St. Petersburg exchange? This seems like a very premature question, I think.
You should ask Pavel Filipov about that, and I vote for the sooner, the better, because while the company is still developing dynamics, or rather, not like that, while the company hasn't grown significantly yet, it's precisely from this point that there will be substantial growth, and then, most likely, the growth rate.
I think, in any case, we need to at least gather the initial necessary amount to. Well, okay, I think that's a different webinar topic.
Invite Pavel Filipov to the webinar.
So, I saw photos on VK of stratospheric envelopes. What achievements are there in this area? This is probably about the last post we uploaded. There's an envelope 500.
Well, these are technical envelopes, yes, essentially for quick and easy tests. Launches will happen soon. We'll probably invite Arkady, because the pace of evolution has changed. There's a lot of interesting stuff to talk about. There are a lot of successes, all related to engineering solutions, and the complication, and further complication of the stratospheric probe. Refinement of the mathematical models has also occurred in recent times, and some concepts regarding controllability have been significantly improved. The upcoming launches will specifically aim to identify this very in-depth concept of altitude retention. Furthermore, let's discuss the stratosphere separately later on in the near future.
Well, there are already a lot of questions here. The polar vortex has broken up. When will you be launching the stratospheric probes?
Yes, indeed, they can absolutely be launched any day, even tomorrow. The polar vortex is not absolutely necessary. In fact, the current weather in the stratosphere is more favorable for testing our stratospheric probes because now the stratospheric winds are moving from west to east at a very low speed, and we can make predictions. When there was a vortex, we could launch it, and it would travel over the territories of other countries, so to speak, and it would almost return to us in about 3.5 days, but now we can launch it, and it will fly over our territory for a long, long time, and we can test everything, detach it, retrieve the payload, without worrying that it will fly to the other side, or that we won't be able to retrieve the payload there. So that's a plus for us. Now the vortex, it's kind of polar again, but now it's not northern, it's southern. Now it's spinning from the south. There's an idea to manage to launch into the equatorial vortex, stratospheric, from some equatorial African side this summer, which would also be nice. We'll see.
It would be interesting to get such data precisely over the equatorial latitude, since it's completely different there.
The data, the experience, it would be nice to get that. By the way, regarding the infrared radiation data, it's very interesting. Winter, summer, water, land, different altitudes, cloudy, not cloudy. Well, here it's all about experience, launching more, and refining the models. It's still equatorial, like a circumnavigation. It's not like a vortex shifted from the pole, couldn't do it. But here, if you go withstand all these.
That would be quite a serious record, I think. Well, for us, yes. We'll do it. So, can we assert that stratospheric probes as a platform have been established for various payloads, for different clients, and everything has already been worked out?
We can definitely assert that we have mastered the technology of manufacturing load-bearing shells, currently up to 2,000 cubic meters. So, right now it's a small one at 500 cubic meters, but the production process was refined to the point that from this same thin film, during the factory tests of the first shells, which we didn't show on air, meaning our shell with nearly zero pressure, even then the seams would come apart due to some wind fluctuations, among other reasons. Overall, it was quite disheartening. Now, from this same film on the same equipment, just by adjusting the settings, the production process, responsibility, preparation, and so on, it has been refined to the point where a small shell has been made that holds 2 kilopascals. So there was zero pressure before, and now the shell itself withstands 2 kilopascals. That's quite a lot. We have mastered the production process for making these shells. We have mastered the production process for making high-pressure shells, ballast, and a whole bunch of small elements as well, which make up everything right up to the preparation for launch and the launch itself. Launch. We have undoubtedly made substantial and significant progress towards being able to confidently approach the customer and have them look at us and say, these guys will absolutely and definitely do it great. So,
next question. What kind of airfield are you going to buy?
A small one, perhaps. What kind?
Here, it's probably about the minimum requirements that are for us.
Civilian aviation, yes. We're looking if there are any. to ensure the documents are in order. In fact, what really matters is its size, that it is as flat as possible and without rivers, hills, and other such features, because an airfield is mainly made either for airplanes or helicopters. It's a narrow flat strip with an approach from one side, maybe from two. We need a 360-degree approach to the airfield. The airfield must be large for an airship if we plan to build and test large airships on it, and we do plan to. The requirements are essentially geodetic.
Okay, what will be the dimensions of the hangar for the new NOVA-35 and what type of construction is planned, like inflatable or permanent?
The new and innovative NOVA-35 model is designed to be a permanent fixture in its environment, boasting impressive dimensions. Its size will be approximately 160 meters in length, with a width and height that could each reach up to 50 meters. This remarkable structure is intended to be a lasting presence. This particular structure is highly likely to be a metal frame, with a 99% probability, which is quite significant. Additionally, it also has an 80% probability of having vertical walls and a reinforced gable roof, which is quite typical for such constructions in this category. This is in regard to the new NOVA-35. We haven't started designing this serious boathouse yet. We're still at the concept stage. Is one NOVA-35 being built there or two NOVA-35s? No, there are definitely two NOVA-35s being built, but in length, it might be such that the next Nova would fit just one. Most that's how it will be. Give or take a few dozen meters, but that's the structure. Naturally, the building is permanent. We don't want to make it with an inflatable frame, and there's no point in doing so because it's an assembly shop, not a shopping center, and the airship is rigid. You need overhead cranes and much equipment to move. Here you really need solid structures and a load-bearing ceiling.
Continuing on this topic, will there be enough space at the purchased airfield for large hangars for vehicles over 200 tons? But that's just a thought, and potential future expansions.
That's exactly what we're considering.
With the prospect for further growth.
So that one 200-ton truck can fit, yes.
So, what will be the power plant or plants on the NOVA-35, its parameters, if such information is available?
No, you need to call Vadim Zukovich for that information. For now, we're actively building only the structural frame for the NOVA-35. There will be many distributed hybrid power plants. Most likely, the same as on the NOVA-8, there will be, well, I won't get ahead of myself, from approximately 300 kilowatts per main propeller, as expectedly anticipated. Propellers along the body, in the range of 300 kilowatts or so.
Many. All right, next question. Right now, the world has suddenly returned to the topic of airship construction. Do you keep your finger on the pulse? They ask, do you keep your finger on the pulse and follow the development of other projects that, as I understand, are progressing in this direction? There are none in Russia.
I think we are even setting the pace. It's not we're keeping a close watch.
Great. Are there any familiar companies or projects abroad, like?
In America, our airship specialists have contacts. China is familiar. Ours know the whole world. So we are familiar with everyone. And do we interact with them? Yes, we actively communicate too. We interact with some of them.
All right, good. What if we use abandoned quarries instead of an airfield?
That's an idea. It's not advisable. There's a story that even planes experience a drop when flying over a quarry. And an airship is more sensitive to such atmospheric fluctuations, so it's certainly not advisable.
Plus, in such places, there is usually increased radiation activity in some quarries.
depending on what they are extracting. In many cases, radiation. Here it's more about the convenience of operation. It's inconvenient.
All right, please tell me about the power plant, everything. What are the airships like?
Which specific airship are you referring to? Most likely, this is about a hybrid. We'll explain. Hopefully, soon.
So, can the NOVA-01 perform a Nesterov loop? I was asked this question, by the way, in your absence at that webinar. I speculated, but I don't know. What do you think?
Can it be done? NOVA-01 in the form factor that we are currently developing as a copy of NOVA-2 cannot. It might. That's a fact. But when we redesign it, we'll try.
If such a task is set, we'll try. No, however, when we take the time to redesign it with a focus on achieving the most optimal form possible, it becomes quite likely that the new design will function as intended. This process involves careful consideration of various factors. At least, many already have the desire to try. How exactly do you plan to get permission to take to the skies?
The permission has already been agreed upon in the near future.
So, there aren't any sharp problems in this direction.
Yes, moreover, our first airship is still unmanned, and it all comes down to the fact that, in general, drone owners already know this procedure. That you can get all the permissions to launch an unmanned vehicle with a few clicks. You need a license, but we are getting help on this front.
Plus, there is already some legislation in place. Not too long ago, airships were even flying over Moscow.
Well, recently. For us, it's been a while, but for them, it's recent.
So, is the polar stratospheric communication seasonal? After all, the polar vortex has dissipated.
There are several models for establishing communication. When the polar vortex is present, that's one model for maintaining communication. When the vortex is absent, the devices can almost remain static. That's another model. But overall, it can be ensured both ways. The only question is the size of the grouping.
Interesting. If the ruble remains stable at approximately 40 rubles to the dollar, it is important to note that. Do I understand correctly that the project amount will need to be increased to more than $100 million?
That's quite a little provocative question. No, not provocative. It's more economic, political. The question is what will happen to prices within our country if the ruble stabilizes at 40 rubles per dollar, whether prices for metal and sausage will also stabilize or not.
It's an open question, yes. So, the maximum speed of the airship.
Well, for a classic airship, how much can it be? 80 kilometers per hour. The larger the airship, the faster it can fly.
Its useful metrics increase there. Are there any additional, reliable documented facts about the maximum speed of an airship?
Well, they all flew up to 100.
Did they definitely fly? I've heard that modern airships can even reach 150.
It's possible, but not useful. Larger airships fly faster, around 100 kilometers per hour. Smaller ones are slower, larger ones faster. But if the goal is to build a high-speed airship, it's quite easily solved. The airship is built to be a bit more aerodynamic.
Hybrid?
Yes, exactly, and it ascends to certain altitudes where the air is thinner. It can fly faster there. Yes, the only question is whether that's the goal. It's solved, and they can be accelerated up to 300, and the stratospheric airship is on the left. Here's our stratospheric probe, so to speak, yes, relative to what to move. Our stratospheric probe, which was in circular flow, was flying there hundreds kilometers per hour.
The maximum hit 170.
And the stratospheric current speeds to 300. A floating balloon flies in the airstream. The air is stationary relative to it, but relative to the Earth, we are flying very fast. Yes, and there are quite fast currents on our planet. They are not actually that high, and they are quite predictable. Just like the Gulf Stream in the water, we have similar currents on our planet, and you can send airships there and kind of use the speed of the current, plus at your own speed. And overall, yes, relative to the air, you won't be flying that fast, but relative to the Earth, you will be moving quite quickly.
Plus, I believe strongly I learned from you that there are also layers and complexities of these winds, vortices, and intricacies, and if you give a stratospheric probe the ability to adjust its altitude, it can migrate through these winds in that way.
Yes, this is a method of moving, specifically maintaining the zone of the stratospheric vehicle, but the airship itself and its maximum speed are relative to the wind. For classic shapes, it's around 100 kilometers per hour, give or take, depending on the shape. But relative to the ground, considering the wind, it depends on the wind speed and the altitude. If the task is to do it quickly, it can be done quickly.
All right, next question. How will you protect the electric motors on the airship from lightning strikes?
Aviation such as helicopters and airplanes are protected. The lightning rods and lightning protection systems are available. Known methods.
Yes, even if they don't have electric motors, there's more than enough electronic equipment that can also take these lightning strikes, but there are protection measures in place to avoid that.
Onboard computers are more delicate than electric motors, so I see no problems.
So, if two airships accidentally collide in the air, what are the consequences? Like two of these balloons.
I can imagine it. Naturally, it needs to be modeled to understand the consequences, but it would be something like the collision of two ships at sea, if one crashes directly perpendicularly into the other. Something will definitely break, but if it's at some tangential angles, then they just meet.
They smoothly part ways, but again, it depends on whether they are rigid or not. It's quite likely.
Some elements of the structure, in general, will certainly suffer. It's quite likely that the elements of the structure that are supposed to suffer will undoubtedly, definitely, indeed suffer. It's like controlled deformation. Why not make a car that crashes into a wall unharmed? Because it's necessary to properly absorb the impact energy in order to preserve some vital elements of both the car and what's inside. Person. Yes, I'm saying that the same logic will be applied to the airship, so that while some structures will suffer, they will absorb the impact energy, allowing the main structure to remain intact. Everything will be fine.
Have you considered the possibility of using automotive ices on the airship? Roger Monk's skyship flew with engines from Porsche?
Yes, we are definitely considering it. It's quite a viable option. It can be done, and we will most likely make small drones, auto-conversions. In short, we're looking at car engines, including those from Subaru, Toyota, Porsche, and other well-known manufacturers. And there are already enthusiasts who install car engines on the same autogyros, adapting them. With the unmanned airship, it's quite a viable strategy. For manned ones, definitely not. Where people are on board, there are completely different rules. The engine must be aviation grade, certified, reliable, and there are a lot of other requirements. But with unmanned aviation, there are currently very favorable changes in the legislative regulations, and so everything will undoubtedly and ultimately work out.
Great, so it seems like my questions have come to an end. If nothing new has been written, we can probably wrap up. Just one thing, I'll make a small digression. In the last webinar, I promised to give away a hoodie, our merchandise from the company SOLARGROUP. I chose this person, the one who made my last webinar and asked the most questions. That was Gleb Italian. I will definitely write a personal message and make sure to send this merchandise. Friends, we also strongly encourage and ask you to be active, write comments, like, and repost these videos that we post, as it greatly helps the development of the project. You know about this, so don't hesitate, be active, write comments. And, of course, we will certainly conduct more activities to support your morale and definitely introduce some interactivity into our meetings, and we will implement the project together. With your help, this will answer all the questions that were sent to me. By the way, if we have a couple more minutes, we can go through them. I actually responded privately, people wrote to me, and maybe someone else would be interested in getting answers to these questions. No. Let's get to work. Alright, friends, thank you to everyone who joined our webinar today and to those watching the recording. If you watched until the end, join us for our next meetings. Thank you all.
All the best. See you next time. Bye.